I'm Mark Dresner, and this is Forward Focus, a special interview series featuring experts and leaders at the forefront of innovation. Forward Focus is brought to you by the Front End of Innovation Conference, FEI, the world leader in advancing innovation, now entering its 15th year. Joining me today is Ken Savin. He is an advisor in clinical innovation with Eli Lilly. Ken, welcome to the program.
Thanks for having me.
Tell us a little bit about your role and responsibilities.
My real job is to try to inform people about clinical trials as a care option in research, in clinical research. But I do a lot of other things besides informing people about clinical trials. I do some recruiting for clinical trials, and then I run odd projects for other parts of the organization.
Maybe we can get a little bit into that. And I just have a note here in my own notes that your background is actually in chemistry as well,
yeah,
right?
Yeah, I'm a chemist, came into Eli Lilly Company as a chemist in the medicinal chemistry group and have had positions in research as a leader in research and as a chemist, a bench chemist, and done a lot of other things within the organization.
How does that background help you in your role now or in some of the other work that you do around there from an innovation perspective?
Yeah, it's actually really helpful for a lot of reasons. I've seen a lot of different parts of the organization. So I see how things are done all the way from discovery, early discovery, all the way up into commercialization, sales and marketing. So I can kind of piece together the way products are conceived and then developed and then ultimately commercialized. And that allows me to have a picture that a lot of other people just don't. But the real benefit is all the people that I know along the way that I can go back to and say, hey, I need to get something done, and you're the right people to do it.
Right,
so.
Right. That's a very important takeaway, I think.
That is a key piece, yeah. It's the network that is developed.
Yeah.
That's I think the power of staying at a company for a long time and moving around in that company. And you pick up more than just knowledge, it's the people.
Yeah, excellent. Now, Eli Lilly has a long-standing tradition of actually embracing and leveraging open innovation, which you don't hear a lot about, at least not the long-standing part from other pharmaceutical companies. What does that look like in practice today?
So that can be seen in a lot of our products over the years. I think it's where you really see open innovation pay off for big companies. One of our early products back in the 1920s, we developed insulin. Animal-derived insulin. That was a breakthrough in the industry, a breakthrough for humanity in a lot of ways. And that was part of a partnering effort that we had with the University of Toronto. And even recently, things like the application of recombinant DNA technology for production of product, or things like Innocentive. Innocentive was a startup company that Eli Lilly Company started back in early 2000s.
Terrific. A few years ago now, you became involved with the Center for Advancement of Space in Science, or CASIS, is
Yes.
it? Yeah, the acronym. How did you get involved, and what's it all about? What do your products entail?
Yeah, so that's another great story. So they called me up, and they got a hold of me because they asked their partners at NASA who they should go to. Their job at CASIS is to find people in industry or academia that could do work on station, on the International Space Station. And the people at NASA had been doing some work with Innocentive, again, and they said, hey, if you want to do some interesting work with somebody in industry, we call this guy up at Eli Lilly Company, because I'd done some work with them as well. And so that's how we got connected, and we worked out a deal that would bring some people out from NASA and CASIS, and we put together a series of teams at Lilly that would come up with proposals. We pitched our proposals, and we got 4 of them accepted by the combined group at the time. And then those made it through all the hurdles, and now we're launching our experiments onto the International Space Station.
Oh, very, very cool.
It's awesome.
So what do these projects look like? How do they even develop? What did they want you to do when you came in? When you said
so they wanted us to do things that were going to be significant to bettering mankind on Earth. That's really what CASIS's mission is.
Okay.
So it's the Center for Advancement of Science and Space, but their real mission is to do science on station for the betterment of mankind. And that was in line with our mission, right? We're doing science for the betterment of mankind. So with that thinking, we put together experiments that would be of benefit to us here for Lilly and for NASA as well, but ultimately also to improve our knowledge for everybody on Earth. So the theme for our experiments is kind of open. Hey, we're doing things that are going to be valuable to a lot of people, and we're going to share those results with people.
And the work on these projects, is this just the teams within Lilly, or are you working with people from other industries?
Well, that's the benefit of doing this. We couldn't do it all ourselves. So we're leading the scientific piece, the concept, but to actually execute on that, there's a lot of partners involved. So NASA and CASIS bring their whole group of contractors and the experts that they have within their own organizations to help us develop these things. And that's another one of the real benefits to doing this type of work, is that of course we get extra media attention, right? There's the soft benefits of media attention and looking cool to our kids, which is important,
Yes.
and that goes along with your own employee satisfaction and engagement. But we're really also pushing our scientists to think differently, to think about doing things in an environment that they had never considered, and to have conversations that they haven't had since they were young scientists just coming into the company or before. It really pushes you to think about what you know and how you know the things that you do. And from that, you have conversations you wouldn't have otherwise. Well, now you throw in a set of contractors that are totally outside of what we would be exposed to. So these are people at Boeing or Zinn Technologies or TechShot, and they're engineers and they're thinking about doing work in space, and they're trying to solve problems similar to ours, but they do it in a different way, and they talk about it in a different way. And all of a sudden you hear our scientists listening going, I would never have thought of doing it that way. So it's a really powerful benefit that you don't expect when you go into things. But when we set up this whole program, that was the point. We did not know what we were going to get. We did not know what we were going to learn, but we were going to push ourselves. And I have 20 of these great scientists, friends of mine who I've worked with for years, and I wasn't really worried about it because I knew they would see things. They're going to do their science and they're going to get their results, but they're also professional observers, and they're going to see someone else's way of thinking, go, hey, we should bring that back into our organization.
Well, that's a great launch pad for my last question for you, which is, how has it impacted what you do at Lilly?
So, first of all, so I have a network of people, and I work with a lot of different people in the organization, but many of my friends have not. They don't have that same network. So they've had to push themselves, and all of a sudden they're meeting new people. They're working with people they hadn't thought of in the past. They're getting exposure to other parts of the organization because all of a sudden they're needing to pull upon resources that they don't have themselves. And it's also allowing them to see that this is how this company operates. So a lot of people go through their whole career. They go to work, they go to the bench, and they do their work. But when you start to see, hey, there's a bigger piece of it, and we play a bigger role within the company. We're ambassadors for the company. We are the ones who go out and are also looking for new technologies to bring back to the company. Their roles expand. So that's, I think, an unexpected benefit for the employees that are working directly on the project. At the same time, other people in the company who work in human resources or in accounting, they're getting into it because we've made it very public within the company. This is what we're doing, and other people are kind of getting engaged. All of a sudden, they're having conversations with people in corporate communications about, hey, you're going to go talk to the media. What are you going to talk to them about? So it engaged the organization behind something, says, hey, we do really cool stuff, and it's very important. And with the work we're doing here, these are actually going to be things that will benefit our portfolio and benefit people outside the organization as well.
What would you say that the biggest benefit from an innovation standpoint is of being involved with cases, of all of the things that you've sort of covered here?
I would say that I think the organization would say the biggest benefit is, hey, we've got some things that are going to impact our portfolio. They're going to actually someday add to our product line. But at the same time, I really look at it as, hey, I've got some employees to think differently, to get engaged. They have a network outside of not just their own organization, but outside the company.
Right.
And there really is not a limit to what you can accomplish. You can get a team of people together and do anything, and they keep on saying they can't believe it. Hey, we're actually doing this, but we are doing it, and it doesn't mean that someday they couldn't go out and do it on their own in some other part of the organization.
Do you have an example you can share with us of something that is coming out of this?
Oh yeah, so we've got 4 sets of experiments. The first 2 were launched in April. We're looking at the crystal we're trying to build crystals of protein molecules that are targets that we feel are important targets that we're ultimately going to go after as design products to target.
On the terrestrial.
On the terrestrial, yes.
And you're doing this in zero gravity.
Yeah,
though.
so you can make better crystals in a microgravity environment because there's no shearing effect from gravity. So they are more defined, more ordered crystals, and it's like getting a high resolution picture of the 3-dimensional image of that structure, ultimately. We're also right now on station testing a investigational product which allows your body to build muscle mass without having to work out. That's pretty amazing. So for the guys in NASA, they love that, right? Because they've got an ongoing issue with long-term space travel and astronauts waste away. But we're really looking at it as a way to test a product without the compounding issues of having to resist gravity. So you resisting gravity, you're actually working out against the forces of gravity. But in space, you don't have that. On orbit, you don't have that. So we can test to see if that product actually works in a system where the individuals can't work out. Right? So we're testing on mice, and we're going to show that, in fact, they're able to maintain or improve their muscle mass without having to work out. So it's an experiment that we've wanted to run for many years and just could not find a way to connect with NASA and do it. And the Center for the Advancement of Science and Space made it possible. And then we've got an experiment going up in end of June. It's looking at how liquids, solids, and gases mix in a zero-gravity environment. So if you take Ovaltine and you mix it in milk, it sort of floats on top, and then it dissolves in. It gets wet, sinks, and then it dissolves in. And we want to see how significant the float effect is. That's important to us because when you eat a pill, it tends to just sort of float in your stomach. But also in the development group, we make large batches of product in a big tank. And you've got a guy dressed up in something that looks like a spacesuit, and he's shoveling material into this tank, and it's going to sit there and float on top. And we want to understand what the significance is of it, some of it floating, some of it's already dissolved, some of it's wet but not yet dissolved. How important is that float effect? So that's what we're doing with that experiment. It turns out we thought it would be the easiest of the experiments to do. I mean, you're just mixing a liquid, a solid, and a gas. Turns out it's really hard to execute because you've got to have the solid and the gas in the container, and then you have to add the liquid to it in a microgravity environment. And that's not as simple as you would think. And then the last experiment is looking at freeze drying. So when you freeze dry bulk material, like a big batch of some bioproduct, it tends to layer out. It looks like a layered cake if you cut it. And it's all the same material, it's just different forms of the same material. Some of it's powder, some of it's a crystal. And that is not a good thing when you're making a big batch of drug product because you want it all to be uniform. You want product uniformity. So we end up having to run an extra step to sort of grind it into a powder, some uniform format for us. And nobody's sure if that is a result of when you freeze it, you mix it in water and you freeze it, or is it when you try to pump all the water off directly through a vacuum. So it doesn't become a liquid again, it goes straight from the solid to the vapor phase. And so to test that, we believe it's an effect of gravity. So what we're going to do is we're going to make a big batch, and we're going to freeze dry some on Earth. Then we're going to freeze some on Earth, and we're going to launch it up, and we're going to dry it in space. Then we're going to freeze some in space and dry it in space. And then we're going to freeze some in space and drop it out of orbit and take it to one of our facilities and dry it there. And from that, we should be able to tell, is it the freezing or the drying? And then once we know that, then we can try to attempt to resolve that issue.
There's a lot going on.
There's a lot going on there, definitely. Yeah.
That's fantastic. I love just dropping in the line, and then we're going to drop it out of orbit.
Yeah.
You know, what a great opportunity. But I love your point about working with people who are really going to think entirely, come at a solution from an entirely different direction. An engineer versus a chemist versus what have you is really extraordinary stuff. And thanks for coming and sharing this with us.
Thanks for having me. This is great.
Yeah. That concludes this episode of Forward Focus. If you'd like to learn more about FEI, the Front End of Innovation Conference, now entering its 15th year, please visit us online at frontendofinnovation.com. Until next time, I'm Mark Dresner. Thanks for tuning in.